Going. All right.
Hello, folks.
Who is ready to talk about ZK? We're talking about Levitation Protocol today. We've got the man, the myth, the legend himself, Stan Kladko here, Dr. Konstantin Kladko to be accurate. So Stan, I know you've been having a lot of fun digging into ZK. You're a builder. This is like a new fun area, which I guess you've known about ZK for a really long time with your background in cryptography. But are you having a good time working on this?
Yeah, totally, Jack. You know the story that probably not known to everyone, but known to you definitely. That for the last year we've been researching ZK and going deeper and deeper and deeper into it, and we asked the question how we can help the community and what are the key things we need to do from ZK point of view. And when we thought about this, we realized our customers, what they said they wanted ZK pretty much on every scale chain. They wanted existing scale chains to run ZK.
Yeah, and as an option, and it's also cool. All the other devs, all these builders, right, are saying, "Hey, let's build a ZK for scale. Let's build a ZK for scale." And us, we're kind of coordinators as core team members of this open source effort. Like if you go to the Linux team, there's a lot of people, contributing, but there's some people that are trying to guide all the efforts. And so, yeah, I felt, and I think one misconception some people have is, well, will scale be only ZK or will there be free gas fees and also ZK? So maybe answer that one first, and then we'll go into the community questions, because I feel like I've had that asked to me like 50 times.
Totally, Jack. RZK actually, it's kind of fun to say it, but RZK is going to be probably the best because it's going to be decentralized. It's going to have all of the ZK capabilities, but also will have to keep the zero transaction fees on the existing chains. So it's not just ZK, it's just keeping whatever is great on scale, the fast finality, the gas-free environment, and actually adding more. So I think our stuff is going to be really, really interesting.
Okay, awesome. And Stan, you had a good a good analogy the other day, or not an analogy, but a scenario where you said, well, hey, let's say I'm a game and I've got 20 million, or 2 million players, and they're doing 20 million transactions, every 6 hours, but they're also minting some really valuable NFTs. Well, you might, as a game developer, make it so when they mint these really valuable NFTs, you pay this extra fee to stamp that to the mainnet through a ZK rollup. But then they're doing all this gameplay transactions. They don't want to spend ZK transaction fees because it's impossible to have zero fee ZK transactions. So I thought that was a good analogy where they could be using both the current scale dynamic for the high volume gameplay, and for these really expensive NFTs that are being minted, then they're using a ZK rollup. And it's a very real world scenario where that makes a ton of sense to add ZK to scale. So that was great. Okay. All right. Well, hey, let's get into it. GLA, thank you, GLA, for this question. What are the most fundamental differences between the Levitation Protocol and other ZK protocols, Stan?
Totally. So, when we started to think about this, what users want, right? The users want cheap transactions, fast finality, high security. They want ZK, and it seems that it's impossible to all satisfy all of those things. High fast finality, cheap transactions, ZK, security. And what we realized after a long time, after that we had many iterations, and we didn't start with the design that we have now. And at some point, we actually got to the point when we realized that you can actually satisfy all of them if you run 2 chains. And it's like in an Inception movie, dream inside of a dream. In our case, it's chain inside of a chain. So we're actually running a ZK chain inside existing scale chains.
That's fun. Yeah, it's like you're here and then you're here, but it's all interconnected. Okay, so yeah, and I think for me, it's like other ZK protocols are literally trying to invent their ZK, and they spend all this time, money, and effort making a ZK, and then they open source it. And then they're stuck with that one thing. Scale is like not opinionated. It could have partner with lots of ZK solutions, and if a new better one comes along, it can just fit in. It's a wrapper, and the Scale token is used to secure that chain because there's this, this whole processing that happens before and after the ZK computation, and that's what the Scale token does, is it secures that and pays for that, and then the ZK payment pays for just that processing and that execution. So it's a good, we have the luxury of this business model where other pay per transaction chains probably don't have the unit economics to make this even affordable to do all that work around the ZK in terms of the gas fees, right, Stan?
Totally, absolutely true, Jack. And the funny thing is that, our things, we have been always strong about decentralization and provable security and provably secure networking. So Scale chains are decentralized. And so we're actually contributing to the community, to the ZK rollup community, because when we do this inception style running of a chain inside of a chain, the ZK rollups we run become kind of magically decentralized, right? That's really interesting. That's really an interesting thing we are contributing, the decentralization.
Yeah, and it's so important from core principles of blockchain. I mean, how far have we progressed if we just have, we use Ethereum to stamp these things and say they happen, but we just have all these companies running AWS servers and monetizing, getting rent. It's how far have we actually moved forward? Yeah, there's a proof validation that they did it, but if it's all centralized, it just makes you even question some of the core reasons why we do blockchain.
Absolutely, Jack. And I think it's a symbiosis in a sense. You can view this as symbiosis because the existing ZK solutions, they are great mathematicians, and there are a number of you can name a number of existing ZK solutions just from the top of my head, like Polygon or ZK Sync and Scroll and Linear and many other people we are talking to, and they're fantastic mathematicians, and they do great scientists. But now they need to decentralize because ZK by itself is centralized. So Scale is actually contributing to ZK community by taking existing ZK solutions, which are fantastic, but at this moment centralized, right? And decentralizing them using this protocol, this Levitation Protocol we came up with, which actually runs ZK rollups on Scale chains without modifying them. That's really the idea.
Yeah, awesome. Okay, all right, next question here. This is from Rohit. My question is, optimistic rollups have lower costs, so why are we opting for ZK rollup, which will have a higher cost? And that's, so Stan, I think that we probably would disagree with that, but it's a good question. It's a good opportunity to, address that. What do you think?
I think ZK technology, one way to understand ZK technology versus rollups, optimistic rollups. Optimistic rollups are great, but they're not progressing so fast. The ZK technology, it's not only the new mass that exists now, but there's a huge progress over the last year or over the last 2 years. So by joining the ZK movement, we're also kind of joining this momentum, and it's super interesting. So I think pretty much all scientists at the moment agree, all computer scientists agree, that long-term, ZK solutions are way better in every way. They're faster, they're cheaper, there's going to be huge progress. So we are not only doing things today, but we're investing for the future. That's why we decided to squarely join ZK movement in a sense that, we target ZK.
Awesome. All right. Okay, great. Here's one from Donald. This is a good question here. I like this. Okay. Could you provide a detailed explanation of the cryptographic primitives and algorithms used in the Levitation Protocol for achieving decentralized zero-knowledge proofs?
Totally.
And can you explain the main features and advantages of Levitation?
Totally. So
and I know we have a slide that Rob could share about might be good to use this. Yeah.
Oh, yeah, that's the slide. But that's something. This slide is like a result of like a year of work that our team has been researching. So what we did, we essentially, it's all open source, right? So we looked into pretty much like each and every ZK rollup available on GitHub, and we tried to analyze them and find commonalities and differences. And what we realized that pretty much every rollup has the 6 steps that I'm going to describe in a moment. So the 6 steps of pretty much every ZK rollup are users submit transactions. Transactions are in the pending queue. Transactions are assembled into blocks. Number 4, this number crunching, super magic mathematics happens. It generates the proofs. Number 5, the proofs are relayed to the Ethereum mainnet. And number 6, the proofs are verified on Ethereum mainnet. And what we realized that out of these 6 steps that pretty much every ZK rollup does, we can actually do 1, 2, 3, and 5. The 4 steps we can do in Scale, in Solidity, totally decentralized. And then we basically leave step 4, number crunching and proof generation, and step 6, which is verification, which is actually also happening in Solidity by a smart contract which is specific to the rollup. So several analogies. What we do, we take these guys and we run them in a common environment, and out of the 6 steps, we take care of the 4 and leave them these 2 steps, which is like pure hardcore math that they have been doing. But the interesting thing is that you got to realize this, that these 4 steps that we are taking and running, they were centralized. So essentially, we're using the magic of Solidity. We're taking steps that were centralized, like block assembly, for instance, transaction pending queue. And by rewriting the code simply in Solidity, these things become magically decentralized because Solidity runs on a decentralized network. So we figured out a very simple way by re-implementing these 4 steps in Solidity, we magically make these things decentralized. And that's why I'm talking about the inception, why I'm talking about this inception analogy, because when you, for instance, do blocks or pending queues in Solidity, it's actually doing a chain inside of a chain, because Solidity already runs on a chain. So there is this super interesting inception moment where something which was used to be run off-chain and form the foundation of a chain actually runs now on top of another chain, and you have this inception. And just to make fun, you could have levitation inside levitation inside levitation, very much everything you had in the Inception movie you could do in this case. But there's this key idea of this self-referential running one thing inside another. And what the idea gives you, it hugely shrinks the development time because it's already decentralized. The only thing you need to do, you port the code which is centralized into the Solidity code, and Solidity is decentralized. Every single line you could ever write in Solidity is magically decentralized, right? So we got to the point where there was this aha moment where we said, wow, that's interesting because it's not also only exciting, but we can implement this fast, and it probably won't take so many lines of Solidity code. So we came up with this really, really interesting idea, and we've been talking over the last probably a couple of weeks to many people in the industry, and just describing them the idea, and people are really excited. I think it's just a really interesting thing to do. But yeah.
So Stan, here's a question for you. How does Scale plan to use BLS threshold encryption in this mechanism, and what value does it provide?
Totally. So that's a super important problem. If you look now at like Ethereum ecosystem, and we are part of Ethereum ecosystem, what are the main problems? What are the problems? Pretty much you go to any conference, you see 2 problems. One problem is decentralization of ZK rollups. And the second problem is MEV or front running. And actually with this solution, we can solve both problems. So I already described how we solved decentralization, just basically running in Solidity. Now let's describe how we solved the front running / MEV problem. What is front running or what is MEV? Simply means you send a transaction and someone else finds out about it and front runs your transaction, sends something that takes advantage of you. Essentially, you're trying to get into a bus and someone cuts in line in front of you and sits on the seat that you wanted to sit on, basically. So for a long time, SKALE had this feature, this idea about this threshold encryption, where when you submit transactions, it's encrypted, so people don't know. People don't know which bus are you going to jump into, and that's why they can't take your seat, because it's all encrypted. And then once you are in the bus, then you decrypt yourself, so to speak. So the idea is that if you decrypt after you are in the block, if you are a transaction, and if you decrypt it yourself after you are in a block, then others can't front run you. That's the idea of threshold encryption. And now it's like this thing actually has become so important because when you talk to people in conferences, they basically tell you about this decentralization problem. And then the second thing they mentioned, okay, but also, so rollups have to be decentralized, but they also have to be protected against MEV and front running. And we think we do both. Just another analogy, just one more analogy. Another analogy. Let's say you have your transaction is a letter, and what you do, let's say you have a letter, and you put your letter in an envelope, and you seal the envelope, and then once you seal the envelope, no one knows what's inside the letter, right? So then what you do, you take many envelopes like this, and you glue them into a chain. And then you have this chain of basically like glued envelopes. So no one knows what's inside. And then after the envelopes are glued, then you kind of sort of cut through them and you see what's inside. That's pretty much the idea of this threshold encryption protection for front running or MEV. Essentially, the transactions are decrypted after they are part of the chain. And then how they are decrypted, they are decrypted, why it's called threshold decryption. It's called threshold decryption because you need to have a group of people, a threshold of nodes of people to decrypt. That's why it's called threshold. So not a single node cannot decrypt. So people say, oh, your block proposer may actually front run. We say no, because our block proposer does not have any single node does not have the power to decrypt. It's only when the chain is glued together, we need 11. I mean, in the case of our standard chains, 2/3, but in the case of our standard chain, it's 11 nodes out of 16. And then they collectively decrypt. So now not a single of them can actually benefit from front running. It's only 11 of them need to get together to do front run and MEV collectively. But then it can be increased, right? We can have a 16-node chain, we can have a 160-node chain. The larger the chain is, the more protection you have, because to decrypt, you have to have this group of people coming together. And if all of them need to be MEV / front running and get together to actually abuse the system, which makes it. And then what's interesting about the situation is that it is super simple. The best thing is that the best things in computer science are always simple. It's easy to explain, right? And I think this threshold encryption is easy to explain. People get it. If it's encrypted, if you don't know what's inside, you cannot take advantage of it.
Awesome. Yeah. Which, if you are doing this ordering and sequencing, and people can see that, and might open the door for them to do malicious things. Whereas, especially in this ordering process, right?
Correct.
Validators,
Correct.
right? Validator could do something malicious to like front run the sequencing ordering.
Totally. And it's I think that if we decentralize and we also add this protections against front running, it's going to be way better than what ZK rollups are now. They are centralized. And I want to say that today's ZK rollups are not centralized on purpose. They are great people, great mathematicians. They're just so hard to do the ZK, then people concentrate on ZK, but it's also hard to do decentralization. Our algorithms are also incredibly complex, and we've been working like for almost 5 years now on this provable decentralization. And it just seems to me that it's a great symbiosis with what our team has been doing and other open source developers in a true open source way, right? We help them, they help us, and together we can deliver what our community has been asking about, actually running ZK on SKALE chains.
Yeah, great, awesome. Okay, Stan, that was a great answer. All right, here we go. Paragon 49. Does the implementation of Levitation Protocol impact TPS? So basically, would this make the TPS lower in scale, or would it not have any impact?
So you're asking this question, like
this is from Paragon 49, yeah.
From Paragon, okay. Good question. So the question is, how is it going to affect performance? So let's get back to this inception thing, right? So we're running this inception levitation. We essentially are assembling blocks inside the smart contract. So what the smart contract does, it actually accepts transactions and then glues them into blocks. So actually gluing and accepting is not so much computationally intense compared to things like crypto, right? And as we just discussed, out of steps 1 to 6, we take steps 1, 2, 3, and 5. But the heavy step number 4, the crypto step, is going to happen off-chain. So it may actually, everything affects performance a little, but we see no huge effect on performance. I think it's going to be pretty much the same because the hard work is going to be done by off-chain. And then the agents that will actually do the number crunching, in some sense, they become almost like, in a sense, like miners, I could say. I mean, it's probably not a fantastic word, but they're number crunchers. So essentially, we have the chain that is can be super light. We don't actually overload our chain because the number crunching is actually the only step that happens off-chain.
Yeah, and I think it's a good question because, some people might say, well, hey, is this going to take away a key metric that's a success metric for scale? And I think not at all. I think it will just, I think for these high value Web3, blockchain gaming transactions, that are really expensive, that you care about really expensive items, and you're going to pay that extra penny or whatever, post that to the mainnet, or 2 cents, or 5 cents, or half a cent, whatever the price ends up being for ZK. But at the same time, if you have somebody executing all these smart contracts in a game, you're just going to keep using scale for that high volume throughput. And I don't really see. I think it'll just add transactions, would be my guess, to the network. It just adds another use case and brings in more, brings in more DeFi, more high value NFT volume. So that's my personal opinion there.
Totally, Jack. And you remember the story I told you that when we were here in Lisbon a couple of weeks ago, right? And we went to this conference, NFT Con, which was fantastic. I think the NFT conference, and I talked to some, game developers, hardcore gamers, and they told me that, if you look like NFTs, for instance, or accounts, or when you're a teenager and you start the hardcore game player, start playing a game, you don't really think about the value of this NFT, of this account, of this sword, whatever. So this is an actual natural progression. You play the thing and you just love it. You love playing it. So the value is not the start. It's actually the end. Like 5 years later, you become a super player and you have this super account, super sword. So you acquire the value. Why it's important for Levitation, I think, is because when you're just starting, you don't need your account is not so valuable to put it on a ZK. So I think the natural progression will be that people will play the games, and most of them by actually just use the chain we have, But if a particular account or particular NFT acquires a value, people will move it to ZK. So what we're giving our community the flexibility. They can use more ZK, less ZK, more interactivity, more speed. So essentially, that's why we love Levitation, because we can put it on our existing chains, and doesn't really change things for people that have been using Scale before. I mean, just giving them another option that they can use.
Yeah, one of the other things about this is it makes Scale, it future proofs all the work all the people are doing in the community. If you look at the value of zero knowledge proofs, well, today they're not delivering. It's just they're costly, they're slow. But there's a lot of people out there that think ZK is going to be the answer in 2 years, 3 years, and it's going to be the #1 way. And if that maybe they're right, or maybe they're wrong, and we just keep operating as we are and just keep dominating. But if they're right, then Scale has I think the most viable future-proof ZK implementation that capitalizes on its strengths, and it creates partnerships out of what would be competitors, and it creates a lot of win-wins, because what they don't have on a pure ZK chain is the option for a high throughput game to have zero fee transactions that are still secured by an upfront payment and a token. So, if you look at Scale, it has something that these pure ZK chains don't have.
Absolutely, Jack. And I think, if you look at some of our friends / partners, some other projects, everyone is kind of converging. The blockchain space is converging pretty much to the same idea, is that people want different things. But interactivity, we're leading enormously. We're leading in interactivity and zero transaction fees. And this is what actually can give you viral distribution of applications, can give you lots and lots of users. So I think actually this is growing steadily. The people understand that this is needed. So ZK is an important piece, but it's just a piece of a puzzle. And also one has to have in mind, if you just take the analogy of ChatGPT. Let's just take analogy of ChatGPT. Probably 6 months ago, no one knew. Most people didn't know about ChatGPT. People who were experts in AI knew about ChatGPT models. 3 years ago, there was a huge investment, huge improvements, but it was not kind of ready for prime time. So people, the investors, the builders, they were building. General public didn't know so much about ChatGPT. And then there was this hockey stick moment when the technology suddenly crossed this level and it became viral and super important. I think ZK is also this, in a sense that there's a huge investment, there's a huge amount of mathematics, different things, people are trying different things, huge amount of activity. It's probably not yet at the hockey stick moment. So, but by joining this kind of momentum, we are, first of all, our engineers are super excited, our community is super excited, and because the thing is actually improving, we are going to get there probably it's hard to predict, but in a relatively short future, ZK is going to be way better, like a hockey stick compared to where it is now, actually. And so I think that's how we need to view ZK inside Scale, and how we position it for the team. It is an incredibly important project. It's a bit of a research project. It's a new thing. I tell to our guys, it's probably like more like Tesla truck versus Tesla Model 3 for us now. It's a little bit more in the future, but it's incredibly important, and we're just excited doing this.
Great. Okay. Awesome. Okay, we've got 2 questions left. We picked 7 today. This is from Leva Gold. Hello, your idea with a decentralized zcation is very cool. You plan to start development now. So basically, when do you plan to start development, and how do you plan to overtake solutions like ZK Sync and Polygon ZK EVM that are already deep in network testing, market entry? Although they do not have your features, their networks are actively developing in social media and have test nets that last for a long time. So perhaps their solutions can take the market and attract users who are interested in this solution. Also, this is a long question. Also, multiple ZKRs working in one levitation-enabled chain. Will this create problems? So I think, one, we already answered numerous times that, but I want to reiterate that we see, we see what SKALE is providing as highly differentiated, because in one seamless developer user experience, they could use a top tier zero knowledge proof like, Linea from Consensus, or, the ZK Sync if they wanted to plug in, or, Scroll or some other ZK solution. Even Polygon could integrate ZK EVM, but the developer can combine zero gas fees and ZK in one easy to use, simple, integrated chain solution for their application, for their game, etc. And so basically and that ZK partner still can monetize. They'll make the same amount of money in SKALE, maybe not the same, but some, whatever the economics are, they're going to be able to monetize, and so will SKALE by way of the way the chain's already paid for. And so it's a win-win. We take these what would be competitors, turn them into partners, and then at the end of the day, would a game developer want something that gives them ZK and zero gas fees, or just always you have to pay fees? And to us, we think it's a clear, super strong value proposition to those developers to have both. So I don't think it's a competitive thing against them. It's more of if they're smart, if I'm them, I'm going to say, hey, how can I monetize my ZK in the SKALE ecosystem, because it's going to be more attractive. That's our feeling.
Jack, I totally agree. And let me just give our community members just another analogy, just come from a different angle. So you have Windows, you have Mac OS X, you have Linux, right? You have Android, and all of the things run Chrome browser. You can run Chrome browser on Android, you can run it on a Linux, on Windows, right? So Chrome browser is the next level abstraction, and very much the same way, Levitation is a next level abstraction compared to the great projects that you named, and we're actually trying to be absolutely neutral in this case. Our goal is, the perfect goal would be to actually run all of them on Levitation. Levitation is a platform where people can run existing centralized rollups in a decentralized way. So we are, Polygon, ZK Sync, Scroll, Linea, many other things, many of the things are already running inside our research team, just to provide a little bit of information. And we love all of these projects. They're great contributions to the open source community. And definitely there is so much we can do in terms of coding, but in the perfect future, we just welcome to run all of them on SKALE. We will. That's our goal. And we are working hard already. The work is going on hard, and some of this work is not yet on GitHub, but the next couple of weeks you'll see pretty much all of this going to GitHub. One thing about SKALE from the beginning was that we are totally open source. Everything we do is open source, and in the particular case of Levitation, everything which will be happening on Levitation, with Levitation, you'll see real time, like a reality show on GitHub. There's nothing we hide. You'll see clearly, come to our GitHub, you'll see all of this happening. But again, the last, the short thing I want to say, Levitation is not a particular ZK rollup. It's a platform, it's an abstraction that allows people to run existing ZK rollups in a decentralized way, making them decentralized, right? Running them in Solidity. That's how we position ourselves. And because we position ourselves like this, necessarily it's important for us to be neutral, and we are really trying to do it, just help the community.
Awesome. Awesome. Hey, Stan, what about this thing? How many ZKRs could work on one Levitation enabled chain?
How this is gonna work? Just give you like really practical, like how this actually gonna run, right? Basically, you have a SKALE chain. That's our goal. That's the release, right, of a Levitation thing, right? You have a SKALE chain, doesn't have ZK, right? And then you deploy a set of smart contracts, because Levitation is implemented as smart contracts. You deploy the smart contracts on the SKALE chain. You deploy some additional contracts on the mainnet. So there is this basic, and then you choose which rollup you want to run. Do you want to run scroll or linear or Polygon or like ZK? That's the idea. And then you choose which you run, and then basically the off-chain part, it's like a really simple, essentially a wrapper that runs the thing. The existing things, they run like a black boxes. We don't really go into their source code. We run them, and then there is also something which is going to be decided in the future, the economic model, because people who run the things, they'll probably be like Bitcoin miners. So they will be people with GPUs, and the question will become how these people will be how they will be paid for their work. We don't know yet now. The community will have to decide. There could be different models for different chains. Actually, the DApp community that runs a particular chain could decide how they actually pay to people that run this number crunching. So we don't have a solution for this now. It's up to the community to decide, and it may be the right thing to do is just provide no solution, leave it totally open, just for every particular DApp community that runs on SKALE to decide how the things happen.
Okay, great. So hey, last question. This is Liba had a lot of questions, and for all of you who asked questions we didn't get to today, I know there's a lot of questions about SKALE G. We're going to do that next time.
Next time, yeah, it's too much.
SKALE G question. We're going to do a separate SKALE G talk. But all right. So when does development start?
It has already started, and it's going on very, very fast.
Okay, there we go. You heard it here. All right, people. Hey, this was fun. We wanted to do a special AMA to talk about this, and I think Stan in one of the last comments made it really clear what we do or what this is it's not a competitive ZK solution. It is a way to achieve decentralization if you're a ZK provider, and it's a way for developers to have their cake and eat it too, to have ZK and zero gas fee pooled security transactions in SKALE. Okay. All right, everybody. It's been fun. Everybody, I know there's a lot of people listening here who are across the board and different constituents. Last thing I want to say is if you haven't checked out the governance proposal, check it out. I think it's going to be, I'm hearing from the devs working on it, it's going to be put up for vote potentially today. And that will then be a 7-day period for it to be, the mechanism to be ratified. So go check it out, get in the forum. And, if you're staked, go vote. Okay. All right. And if you're not staked, go stake and then go vote. Okay. All right, everybody.
Bye, guys.